Hey, ladies and gentlemen, I just want to go through that Bohr model formative with each and every one of you. So if you take a look at the Bohr models, there are 4 problems. You need to find the Bohr models for aluminum, calcium 42, chlorine as a chlorine ion, and sodium as a sodium ion. So the first one, aluminum. If we look at our periodic table, aluminum, there's a couple things we need to figure out for this. We need to figure out our protons, our neutrons, and our electrons. If you look at the periodic table, aluminum is element 13, which means it has 13 protons. And then we're going to skip neutrons just for a second, because if we remember, if it doesn't say ion or if it doesn't give us a charge, our protons and neutrons need to, our protons and electrons, I apologize, the protons and electrons need to be the same, because we want our charge to be neutral, to be 0, no charge. The last one we have is our neutrons. Our neutrons is the hardest one to figure out because it's our mass number minus our number of protons. So we have to do a little bit of math here. When we round our mass number to a whole number, since it didn't give us one here, we're rounding our mass number to 27 because it's 26.98, and we're going to round that up to 27. And so when we subtract 27 minus 13, we should get 14 neutrons. So then the big thing is to remember that the protons and neutrons are going to go in this nucleus, that center of our atom. So I'm going to draw a little circle, and I'm going to put my protons and neutrons inside. So I'm going to put 13 and 14. My electrons, that's where it gets a little more tricky. So if we remember our first orbital, if we can remember correctly, that first orbital is actually only going to have 2 electrons inside. So it only gets 2 electrons, just like that first row on our periodic table only has 2 elements. Our first orbital only gets 2 electrons. We have to start another orbital. And then if we remember correctly, our next orbital is going to have how many? Hopefully you guys got it correct, with 8 electrons total. We can't have more than 8 electrons on our outermost orbital at the time. So this one right here is only going to get 8 electrons. So I have my 8 electrons for a total of right now 10. Do I have my total 13 electrons needed? I don't. So I need to add another orbital. So I add my third orbital. And for this one, if we look at our periodic table, we only have 3 elements before we get to aluminum. Or if we look, we only need 3 more electrons to get the 13. So we're going to add 1, 2, 3 more electrons to have our total of 13 electrons on aluminum. If we remember also that our valence electrons here are 3 because there's 3 electrons on that outermost orbital. All right, the next one is calcium 42. So the first thing we need to identify is our protons, neutrons, and electrons. Calcium is number 20 on the periodic table, which means it has 20 protons because our atomic number is 20. This is not a charge, this is an isotope, which means that it has 20 electrons. And then that isotope means that it's not calcium 40 anymore. We're not rounding that mass number on the periodic table, but instead we're taking the mass number from right next to calcium. So if we take that 42 minus 20, we're going to have 22 neutrons. We have 22 neutrons, which means that now we can draw our nucleus. I'm going to draw it way over here since I'm going to run out of room. My nucleus is going to have 20 protons and 22 neutrons. Once we have our nucleus, we're going to draw our first orbital around the nucleus. And then if I do this correctly, I should put 2 electrons on that first orbital every time, as long as it goes past that first row. My second orbital gets, hopefully you know or you guessed at this point, it does get 8 electrons around the nucleus on the second orbital. And then we're not done because we need 20 electrons and we only have 10. So we got to add a third orbital. We added our third orbital, and I'm going to put 1, 2, 3, 4, 5, 6, 7, 8 electrons. Can I put 9 and 10 on here? Hopefully you guessed that you can't, because once we put 8, we filled that third row. We can't put more than 8 electrons on there right now, which means that we have to go to another orbital. So we're going to add a 4th orbital this time. And when we add this 4th orbital, we are going to put 2 electrons for a total of 20 electrons around our nucleus. And we're done with calcium-42. This one has how many valence electrons? Hopefully you guessed 2. It has 2 valence electrons. Chlorine ion. So the first thing we need to do is figure out our protons, neutrons, and electrons. So the first thing we find is our protons, or our atomic number for chlorine, which is 17. Remembering that our protons and neutrons are almost always the same. It's going to be 17 electrons, but wait, this is a chlorine ion, which means it has a charge. And we look, it has a negative charge, which means we need more electrons than protons. So should I take away a proton? Or should I take away or add an electron? Hopefully you guessed add an electron, because if I take away a proton, I'm making sulfur, and that is not what we're asking for at the moment. So I'm going to add 1 more electron for a total of 18 electrons here. 1 more electron than my protons. My nucleus has, or my atomic mass is 35.45, which means that if I round that, it's 35 for my mass number. My mass number minus protons gives me neutrons, so 35 minus 17 is going to be 18 neutrons. So let's start with our nucleus again. So our nucleus here is 17 protons and 18 neutrons. Our first orbital is 2 electrons. That second orbital gets 8 electrons. And then this is where we get tricky, because our third orbital, normal chlorine, has 7 more electrons on its outermost orbital. But this is not normal chlorine. This is chlorine as an ion, which means we have to add 1 more electron for a total of 8 valence electrons, or 8 electrons around its nucleus in its outermost orbital. So that 1 more electron gave it its full 8. It made it stable. It made it happy. And then we're done. So then added that 1 to give us 18 total electrons. And then the last one, sodium. Sodium is an ion, so let's come with our protons, neutrons, and electrons. Sodium is element 11 on the periodic table, which means normally it has 11 electrons, but this is a sodium ion, which means we have to change our electrons. Looking at our charge, it's a +1. Positive 1 means we have more protons than electrons. We have 1 more proton than electron. So should I add another proton or take away an electron? Hopefully you remember, just even from chlorine, that if we take away or add protons, we're changing our element. If I added a proton, I would be a magnesium atom, and that's not what we want. We want a sodium ion. So that means we're going to take 1 electron away for a total of 10 electrons. Then if we look at our nucleus and our atomic mass, our mass number here is 22.99, or 23 if we round it. If 23 minus 11 to get us our neutrons is going to be 12. When we make our nucleus, we have, oops, that's too small for me. We have our 11 protons and our 12 neutrons. We're going to make our orbital. Our first orbital gets 2 electrons. Our second orbital gets 8 electrons. And then our normal sodium atom is going to look like this with another orbital with 1 more electron. We're just going to put it right here. But this isn't normal sodium atom. This is our sodium ion with a +1 charge. So we took away 1 electron. So we're going to take away that electron. When I take away that electron, my whole orbital goes away, and I'm left with my sodium atom without the outermost orbital. One thing we are going to do to all atoms with charges is we're going to add our +1 charge outside brackets here. and we're going to put brackets around our chlorine and put a -1 charge. So we remember that those atoms do have a charge. We're not just ignoring the fact that those have a charge. If you guys have any questions, please let me know. Otherwise, here is our Bohr model formative.